everyone, welcome back. This is the video that come with every chapters. So except for the PowerPoint videos, the narratives videos, I will also have this live video for you to actually learn how to get through the homework assignment problems for each chapter. So I think the first question I have to answer you in this video is how you're supposed to submit your assignments, right? So for each chapter, we actually have one chapter assignment asking about some technical techniques or analysis skills for you to solve. So you have to either write it on a paper to answer the questions, or maybe you can choose to type it out if you want. Sometimes it involves graph, but you can definitely use some of the tools on Microsoft Word to type it out. But something very important to note. So your homework assignment has to submit before the due date. So the due date is already on D2L. There is a chance for you to submit the assignment late, but there is a penalty. So you might want to double check the course syllabus. And also, I only accept assignment in PDF files format. So make sure you actually turn your assignment into PDF files. I think if you have used Word before, you can actually type out your answer on Word and then print the file as a PDF file so that you can save it as a PDF format and then submit it to D2L. Or other applications on your smartphone now, they can easily help you to turn your written documents into PDF files. There is one app that I use during my graduate programs, which I would strongly suggest you to try to download it in your smartphone and try to make use of it to turn those assignments into a PDF file. So this app is called a ScanCam. So you can easily find it on the Google Play Store if you're using an Android system, or maybe if you're using an Apple, you can easily find it on the iPhone iOS platform. So you just type out ScanCam and then you will be able to download the app. I will have the information post on D2L for you guys to discover. So today, mainly, we are going to go back to our basic principle concept to talk about elasticity of demand, right? Because that's what we learned in chapter 2. And there is one big question in chapter 2 that you have to solve with this technique here. So first of all, I'm going to use this one example today to illustrate. Sometime we might actually get data from different countries. For example, in this example here, we're actually getting some data from the city of Toronto and the city of Quebec. So basically, both cities are located in Canada. So we do have some data coming from them. So we do have data regarding the quantity of the services, which is the outpatient visits per month for the general population living in both cities, and also the price per visit in those cities. So taking the case in Toronto, the people on average actually visits or having this outpatient visits 1.2 times per month, and the price for every single service, every single one visit, it's $20. In Quebec, it's 1.8 visit per month and $12 per visit. Well, we can easily draw the demand curve by using this data, because we can just assume, okay, well, we would like to estimate the demand for this outpatient visits by using the data from these two cities. Well, we can easily plot this 2 points on a graph and try to explain the downward sloping demand for outpatient visits in Canada. Well, there are some short flow about this analysis here, which we will talk about in just a minute. But first, today's objective is to calculate what we call the elasticity of demand, how sensitive people are in Canada to use this outpatient visits. So there is a section in the book that talks about the elasticity of demand. So there is a few things that we would like to go over today. Number one, why can't we use the traditional percentage equations to calculate percentage change in price and percentage change in demand, quantity demand, and why we are using the arc elasticity of demand instead. So first of all, let me define what is elasticity of demand. So the elasticity of demand is basically calculated by the equation percentage change in quantity divided by the percentage change in price. So let's take a look at this percentage change equations here. So let's suppose if I'm trying to calculate the percentage change in price. So usually people will calculate this percentage change by using the new price minus the old price divided by the old price and multiplied by 100%. However, there is a problem. Let's suppose I'm trying to use this example here to illustrate. If I'm treating the price of Toronto as a old price and Quebec it's a new price. So $12 minus $20 divided by $20 multiplied by 100%. This will give you a different result if I'm actually turning this around. So let's say I'm going to use the Quebec price as a new price and then Toronto price as the old price. So I will get 20 minus 12 divided by 12 multiplied by 100%. Well, it will cause a problem when we actually trying to pick a starting point to calculate this percentage change in price, and as well as the percentage change in quantity demands, the service demanded by the populations. So that's why we want to actually improve our estimates by using a different percentage change equations. So instead of using these equations here, we are going to use what we call the midpoint rule. So the midpoint rule basically is trying to use the same concept here. We're using the new price minus the old price. Now this time we are going to make the bottom parts different. Instead of just dividing the old price, we are going to take the average of the two prices so that we don't get into the problem of picking a starting point. So same as the percentage change in quantity. So we will have the new quantity minus the old quantity and then divided by the average of the new two quantities here. So this is basically what we call the midpoint rule when we calculate the price elasticity of demand. Well, if we combine all this information, well, we finally get this equations for elasticity of demand equals to, well, it's a huge equations, but I can rewrite this here. So Q2 minus Q1 divided by Q2 plus Q1 divided by 2. And sorry about the percentage, so we always have to multiply by 100% for both. And divided by the price percentage change. So this is basically the full equation for price elasticity of demand by using the midpoint rule. And also this is what we call the arc elasticity of demand. However, in this equation, you can kind of tell there are something in the equation we can cancel out. For example, we have 100% and 100%. Well, we can cancel them out. We have this notations here divided by 2. We have this notation here divided by 2. Well, divisions can also cancel out in a fractions. So these two actually cancel out. So at the end of the day, all we have left in these equations, let me rewrite. So all we have left after this durations, we're left with so this is basically the equation you see in the textbooks. So whenever we're trying to calculate the arc elasticity of demand, now we are going to use this one simple formula after deriving from all this information. So we are going to try to calculate first what is the price elasticity of demand for this outpatient service in Canada by using the data from these two cities. Sometimes we just don't have a choice. I'm pretty sure you will argue as well, the people using this outpatient service might be different in many different ways, such as their income or maybe the preference for doctor visits. But sometime when we're doing our research or trying to estimate the elasticity of demand, we come into this limitations of data. So we have to make use of this data. It's not ideal, but we have to deal with it. All right, so let's try to calculate the arc elasticity of demand by using these two data here. So I'm going to keep these equations here and try to calculate the arc elasticity of demand in Canada. So you can now either pick one or the other as the first quantity or the second quantity because, well, we have already talked about when we're using the midpoint rule, which starting point to pick, it's not a problem for us. So for example, let's say I'm going to pick Toronto as my first Q2 here, and then the Quebec using 1.8 visits to be the quantity 1. So let's say I'm going to put 1.2 minus 1.8 divided by 1.2 plus 1.8 and divided by. Now I'm going to use the same patterns here. So when I'm picking Q2 as the patient visits in Toronto, I would like to use P2, the price in Toronto also. So $20 minus 12 divided by 20 plus 12. So here I would like to actually ask you to pause the video just for a second to work out this math. And I'm going to write out this answer in just a second. So hopefully you can try this math on your own and see if that result match up with mine. Alright, so if you have paused the videos, now you should actually resume and let me get you the result that I have. So in this case, by using the two city data, we actually can estimate the elasticity of demand for outpatient service in Canada equals to negative 0.8. So does everyone getting the same answer here? Hopefully you are. Now let's go back to our principal economics and try to understand, well, what does this 0.8 means? So this 0.8 or maybe negative 0.8 means when there is 1% change in price of outpatient service in Canada, we assume there will be 0.8% change in outpatient visits in Canada. Well, the negative sign tells us when the price increases, well, the quantity demands for outpatients will decrease. And when the price decreases, the outpatient service will be increasing. So this is basically the simple concepts that help us to understand how we actually make use of the data in the realities. So the next questions that I would like to ask you is, if we are looking at this graph here, and we are thinking about, well, there should be some differences between Toronto and Quebec. Let's say people in Toronto, they in general has a higher level of income comparing to people living in Quebec, because Quebec is relatively more remote state in Canada comparing to Toronto. Toronto is relatively more commercialized and more more economic activities involved. So in this case, people in Toronto actually earn, in generally, higher level wages or income compared to people in Quebec. How is it going to make a difference comparing the two cities here, and how is it going to impact our estimates from this analysis? So think about this way. Let's say if the people in Toronto, they in generally earn a high level of income comparing to people in Quebec, and they actually have higher level of visits, not only because of the price of the outpatient service. So you can actually imagine, well, people will actually use the same level of services given the price it's higher in Toronto. So that means if we are going to imagine there might be a demand curve for people demanding outpatient service in Toronto, we might actually think about, oh, there is a 0.8 visit here, but people not necessarily will use that many outpatient service given the price of outpatients, it's only $12. They might actually get more of this service if the price even higher than $12 because they have, in generally, a higher level of income. So you might actually imagine there might be a point that's way up here that people might use service in Toronto, given the higher price. So collecting these 2 points here, the true demand in Toronto might look something like this. On the other hand, well, Quebec might actually not able to pay this high price because people in general has lower income. So when people they start deciding to cut down on the number of visits per month, well, obviously they will not willing to pay this high price. Instead, they will pay a little lower price because in general they have lower income comparing to Toronto. So instead of $20, maybe people only willing to pay $15 to reduce the level of visits by this much. So in this case, the true demand curve for Quebec might look something like this. So you can now see, if we have these solid lines to describe the estimates in the country of Canada, well, this data here, or this estimates here, obviously underestimates the true elasticity of demand in both cities, given Toronto has a higher level of income comparing to Quebec, because we are underestimating the elasticity of demand. Well, in this case, well, it's a lot more elastic in the case of this first estimate, comparing to if it is true that Toronto has a high level of income comparing to Quebec, the true elasticity should be less than what we first estimated here. So this is basically the problem we always get into in the study of elasticity of demand, because, well, it's not true that every time we have the same characteristics of both cities, and when we're getting the data from different city or different regions of the city, it might create problem for either underestimating the elasticity of demand or maybe overestimating the elasticity of demand. So we have derived the art elasticity of demand for outpatient service in Canada. The negative 0.8 actually means for every 1% change in price, it will result in 0.8% change in quantity demand for outpatient service in Canada, combining the data we use in Toronto and Quebec. Now the next question we would like to actually answer is, well, if the price of this outpatient service actually go up to $25 in both cities, how is it going to affect the quantity demands in both cities, assuming a constant elasticity of demand? So that means we are basically assuming the elasticity of demand in both countries actually remains to be negative 0.8, regardless how much the price is and how many quantity of service they're using. So in this case, the first step is try to calculate the percentage change in price, because we're already having this elasticity of demand to tell us how much it will affect the quantity demands of the service. So in the case of Toronto, actually the price changing from $20 to $25. So we can actually use the midpoint rule to calculate the percentage change in price, which is we are going to use the new price, $25, minus the old price, $20, and then divided by the midpoint between the two, which is 25 plus 20 divided by 2. So after calculating these numbers, well, easily you can actually get the numbers for this percentage change in price, which is equals to 20.22%. Now, I would say I will leave you the chance to calculate the percentage change in price for yourself in the case of Quebec. So the case of Quebec actually have the price changing from $12 to $25. So you want to use the same logic to apply to this percentage change equations. So the answer that I got for the percentage change in price is 70.27%. So let's see if you get the same result. Well, after calculating the percentage change in price, well, now the next thing we want to do is, well, how much does it affect the quantity demand in both cities, assuming a constant elasticity of demand? So remember, this our elasticity of demand that we got from the previous derivations tell us 1% change will affect 0.8% of the quantity demand. Now the price is actually increased by 20.22%. Well, obviously, Toronto will see the quantity demand for the service to go down by 0.8 times 22.22% that we got from here. So that means in the case of Toronto, well, the quantity demands of outpatient service will be affected negatively by 22.22% times 0.8. So this is the change in quantity demands in percentage. So we can actually calculate this change in percentage change in quantity demands, which is equal to 22.22% times 0.8 is equals to 17.78%. So that means, oh, negative sign is very important. So that means the quantity demand will drop by 17.78% in Toronto. So you can actually use one way or the other. You can actually say, well, by multiplying 1.2, which is the original quantity demands in Toronto, times 1 minus 17.78%. And at the end, you will get the answer equals to 0.987 visits per month. So in general, a price increase in Toronto will reduce the quantity demanded for this outpatient service, which is what we learned in Chapter 2. the law of demand actually tells us the higher the prices, well, we reduce the level of usage of these services. And I will actually suggest you to do the same thing by using this result here. So you know what's the percentage change in price in Quebec. And I would like you to ask you by using this coefficients here to calculate how much it will affect the quantity demand for outpatient service in Quebec. And the results that I got in Quebec the quantity demand will actually drop to 0.788 visits per month. So that's what I got from my calculations. You can actually double check that yourself. So the next questions I would like to actually further discuss is, what if instead of giving 1 year of data in Toronto and Quebec, now I actually have 2 years of data to actually evaluate the elasticity of demand for each city. So after taking a look at the data here, well, now we're not only having 1 year of data for Toronto and Quebec in the year of 2000, which is the original set of data we have, but we are adding 1 more year of data from our data sets. Let's say in the year of 2001, we also have data on outpatient visits in Toronto and Quebec, and also the average price for visits. Well, given this information here, now we can actually derive the elasticity of demand for outpatient service in each city now. So in order to calculate the elasticity of demand for Toronto, let's say, we can actually plug in number into this equations here. So basically we need 2 years of quantity and 2 years of prices. So we are using the quantity in the year of 2000 and the quantity in the year of 2001 in Toronto, and also using the price in the year of 2000 and also the price in the year of 2001 also in Toronto. So by using this equation here, now we can just plug in those numbers and to get the results. So I'm going to work it out one time with you guys. So let's say I'm going to use the quantity in 2001, which is 1, minus the quantity, the visit per month, it's 1.2, divided by 1 plus 1.2, and then divided by the price. So I'm going to use, again, you have to follow the same order here. If you put the quantity in the year of 2001 first, or you want to put the price in the year of 2001 first. So that means you want to use $28 minus $20 divided by $28 plus $20. So once you plug in all this number, you can easily derive the elasticity of demand for outpatient service in Toronto. So at the end, you will get this coefficient equals to negative 0.5556. So you can actually double check the answer yourself. Again, to interpret this elasticity of demands in Toronto, we say for every 1% change in price, well, it will result in 0.5556% change in quantity demands for outpatient service. You can actually repeat the same step for Quebec. So you can actually calculate the elasticity of demand in Quebec. I'm not going to repeat the step here. Instead, I'm going to give you the answer and I let you check the answer yourself. The final answer that I got is negative 0.4556. 0.546. So for every 1% change in price for the outpatient service in Quebec, it will result in 0.4546% change in quantity demands for outpatient service in Quebec. So this is basically a fundamental tools how we use the elasticity of demand in the markets to talk about the sensitivities of a service buyer, or maybe in this case for patients. Well, because of the downward sloping demand curve natures, we always know when price goes up, the quantity demands for this service will go down. And when price go down, the quantity demands for this service will go up. So this is basically follow the law of demand, so there's no surprise. But how sensitive it is, well, depends mainly on, well, what's the population looks like. If we have older generations in the city, obviously those people will require a lot, more of the long-term care service. There will be a little bit less price elastic comparing to other populations. Well, I will strongly suggest you to go back to the assignments and try to work out the problem yourself. Well, basically we have given you some of the most important hints to succeed in the first assignment here. And I will try to put up the next assignment next week for you guys to do. And similarly, I will have the videos to derive this technical stuff so that you can actually work out the problem at home yourself. Don't feel shy to ask questions on the discussion forums. So there is a chapter 1, actually chapter 2 assignment discussion forums on D2L. Make use of it. Try to ask questions if anything that you are not sure, and also help out your colleagues or maybe your classmates so that you can earn those participation points on the discussion forum. So that's all we have for today. I will see you next time.